So for today's lesson, I'm going to discuss with you evaluation of definite integrals. So this time, integrals now have specific values. Unlike what we were doing before, after evaluation of integrals, you will come up with a collection of functions for each indefinite integral that we evaluate, okay? Now this time, so we're going to evaluate integrals and the values are specific. Evaluation of definite integral. How do we evaluate indefinite integral? Let f be a function continuous on the closed interval AB. If big F is an antiderivative or integral of small f on the closed interval AB, then the definite integral which we are going to denote by this notation, okay? The indefinite integral. So with value here at the lower part of the symbol and b on the upper part. And then we have f of x dx. And this is read as the definite integral of f of x dx from a to b. Okay? And this is equal to the value of the indefinite integral when x is b minus the value of the indefinite integral big F at x equals a. When you get the difference of these, that's the value of this definite integral. Note that for simplicity, we are going to denote this difference, big F of b minus big F of a, in the following manner. So big F of b minus big F of a is equal to big F of x evaluated from a to b. So again, we're going to denote this difference by this notation, which means big F of x evaluated from x equals a to x equals b. Okay? And it means, again, difference of these two values. That clear, guys? Okay. So let's illustrate that. No? Let's say I have this definite integral from, let's say, 2 to 4 of small f of x dx. So it means it is equal to capital F of 4 minus capital F of 2. So once you know the actual antiderivative f, you will be able to evaluate f of 4 and together with f of 2. Just get the difference. That's the value of this definite integral. Okay, guys? Notice that in definite integral, the constant of integration is not anymore written. Okay? So it is not anymore present. So because as I mentioned, definite integral is a specific value. Unlike indefinite integral, it is a collection of functions. By the way, here, big F is an antiderivative of what? Of small f. Where F is what? Is an antiderivative meaning integral, no? Integral of small f. If, for instance, I have integral from -5 to 7 of, let's say, f prime of x dx, since this is already derivative notation, f prime, so I can have it f. Because if I have f, what's the derivative? F prime. Okay, so f of 7 minus f of -5. Look at the first example. This is small f and this is big F. Okay, if I get the derivative of big F, so it is f prime. Okay, I mean it is the f, no? Yeah. The derivative of this big F is the small f, or the derivative of capital F is capital F prime, and that capital F prime is the f. So let us have the last one here. If I have integral of, let's say, -2 to 4 of, let's say, g double prime of x dx, so it is now here g prime of x, and but what is our x at the upper limit? So we have 4, no? So g prime of 4 minus g prime of -2. So that is what it means. By the way, here in this notation, we call this a lower limit. Lower limit of integration. And we call the b upper limit. Okay, guys? Yan. What if we know the actual f of x or the actual f prime of x or actual g double prime of x? So let's now proceed to actual evaluation. Of definite integrals, no? So evaluate the given definite integrals. Are you okay, guys? Guys?
Yes, sir.
Yes po.
Okay, number 1. Integral from -1 to 2 of, let's say, 2x minus 3. So what is the value of this definite integral? Definite integral, by the way, can be negative, can be positive, or can even be 0, no? Yeah. So this is equal to, first we have to get the indefinite integral. What is the indefinite integral of 2x minus 3 quantity dx? So that is x squared minus what? Minus 3x. Am I right, guys? So again, evaluated from -1 to 2. So this is how we write it, this notation. our big f of x is x squared minus 3x. No need for constant of integration, because if you write that, that constant of integration later will vanish, all will disappear. Kaya no need. Okay, guys? So this is equal to, so how do we evaluate this notation? The value of x squared minus 3x when x is 2. So that is 2 squared minus 3 times what? 3 times 2. Then minus the value of this x squared minus 3x when x is negative 1. So we get negative 1 quantity squared, then minus 3 times negative 1. And then simplify, no? So 4 minus 6, that is negative 2. Check my evaluation, guys, ha? Minus 1 plus 3, no? 1 plus 3, so that is 4. So negative 2 minus 4 is equal to negative 6. Okay? So the value of this definite integral is negative 6. So how do we interpret the value? It means you have a region and between, for instance, between the graph of 2x minus 3 and the x-axis, and perhaps the region is more on below the x-axis. The reason why negative, or possible also that the region is totally below the x-axis. Because definite integrals interpretation generally is signed area of the region under the graph of f of x, or below the, above that region or below, no? And the region can be what? Can be below the x-axis or above the x-axis. So that's the value, negative 6. So let us have number 2. We have integral of 1 to 3. We have 3x squared minus 4x plus 5 quantity dx. What about this, guys? So what is the integral of 3x squared, guys? So again, we have to find first the indefinite integral. So we have x cubed, na? Second term, that is 2x squared. Third term, 5x. Okay? Evaluated from negative 1, from 1 to 3. So let's now compute the value of this indefinite integral when x is 3. So 3 cubed minus 2 times 3 squared. Then plus 5 times 3. Then minus the value of this indefinite integral when x is 1. So 1 cubed minus 2 times 1 squared plus 5 times 1. Well, let's simplify its expression. So for the first expression here, that is 27 minus 18, no? Plus 15. What about the second group? We have 1 minus 2 plus 5. Simplifying further, so we have 27 minus 18 plus 15. So that is 24 minus 1 minus 2 plus 5. That is 4. So 24 minus 4, that is equal to 20. Okay, guys? So the value is 20. Is that clear, guys? So Let us have number 3. Integral from 0 to 9 of, let's say, let's change the lower limit. 1 to 9 of, let's say, 6 square root of x minus 1 quantity dx. Yeah, what about this? So again, first we get the indefinite integral. So what is the indefinite integral corresponding here? So 6 times. So what is the square root again, guys? Square root means, square root of x means x to the 1/2, right? Okay, guys? So that is 6 times u to the n du. So that is u to the n plus 1 over n plus 1 minus integral of 1 dx. So that is x. Again, evaluated from 1 to 9. So simplifying this, 6 divided by 3, that is 2 times 2, 4. 4. Then we have x to the 3/2 minus x. Okay? Evaluated from 1 to 9. And this is equal to, what is the value here? So we have 4 times 9 raised to 3/2 minus 9. Then from here we get the another value. So value of this when x is 1 this time. So minus 4 times 1 raised to 3/2 and then minus 1. Okay, get the difference. So by simplifying its expression inside brackets, no? 4 times 9 raised to 3. Let's take the square root first. The square root of that is 3, no? Then raised to 3. So giving what? Giving 108. So we have 108 minus 9 minus, this is 4 minus 1 only, no? Am I correct, guys? Square root of 9, that is 3 raised to 3. And then we multiply it by 4. So that is 108. Then minus 9, no? So simplifying further, we get 109 minus, 108 minus 9. That is 99 minus 3. So getting 96. Am I correct, children? Guys?
Yes po.
Yes, sir.
Okay, so let's have another one. Integral from 0 to 7 of square root of four plus 3x dx. So how do we evaluate the corresponding indefinite integral? We can apply what, guys? Simple u substitution, huh? So our u here is what, guys? 4 plus 3x, right? Guys? Then, what is our du? 3dx. Hence, we get, remember, square root means the order is what? Is 1/2. So n is equal to 1/2. So this is u to the n, which is 1/2 the n, and the du is what? It's supposed to be 3. So let us supply 3, balance outside by 1/3. So getting 1/3 integral from 0 to 7 of what? Of 4 plus 3x raised to 1/2 and then multiplied by 3 dx. Then times 3, then dx. Again, I introduce 3, I balance it outside. I applied correction factor. Okay, guys? So we are now ready to evaluate this integral. So this is equal to 1/3 u to the n plus 1 by general power formula. So by this time, you should know how to evaluate indefinite integrals. Huh? So plus 1/2, 3/2 all over 3/2. Again, we omit the constant of integration. Okay, if you are evaluating definite integrals, no need for constant of integration, because if you do, so that will just disappear later. So 0 to 7. Okay, so this is equal to what? 2 over 9, no? So 2 over 9 times. So let's factor out 2 over 9 and evaluate this 4 plus 3x quantity to the 3/2 when x is 7 and then later when x is 0. So let's begin with the upper limit first. You begin with the upper limit, huh, guys? So 4 plus 3 times 7 raised to 3/2 minus, when x is 0 this time, 4 plus 3 times 0 raised to 3/2. Okay, guys? So by the way, notice that I put the 2 over 9 out already, huh? So actually, each term has 2 over 9 factor. So 2 over 9 times 4 plus 3 times 7 is 25. Am I correct, guys? So raised to 3/2 minus 4 plus 3 times 0 is what? 4 raised to 3/2. Okay, guys? What is that equal to, guys? Guys, so 2 over 9. What is 25 raised to 3/2? What's the square root? 5. Guys, so what's the square root? 5 raised to 3, 125 minus 4 raised to 3/2. So square root is 2, cube it, 8. Okay, so when simplified, this is equal to, what's the value, guys? 125 minus 8, that is equal to 117 divided by 9 times 2, and that gives us 26. Understood, guys?
Yes, sir.
Okay, let's have number 5. So as long as you're very good in indefinite integration, so no problem for definite integration, because definite integration is simply getting the difference between difference of the value of the indefinite integral at the upper limit minus the value of that indefinite integral at the lower limit. Okay? So let's have integral from 0 to square root of pi. Then we have p cosine p dp. What about this? So what is our method that we are going to apply here? Is it simple? Is it basic integration, or are we going to use technique of integration, guys? Technique, no? So this is integration by parts. So again, by integration by parts. So what is our u? Cosine p. Sorry, it's p. Huh? By Liate. What is dv? It is cosine p dp. Okay? So what is our du? dp. What is our v? We have to integrate. That is sine p. No need for constant of integration. Okay, guys? So we now have uv. So what is u? Let's, I think, let me rewrite this in v. So ub, that is p sine p. P sine p minus integral of v du. So that is sine p dp. Okay? So the whole thing evaluated from 0 to square root of pi. Okay, guys? So this is p sine p minus, or what is the integral of sine p dp? That is basic integration, negative cosine, so negative, positive now. Okay, guys? Evaluated from 0 to square root of pi. Okay, let's now find the value of this indefinite integral when p is square root of pi. So square root of pi sine of square root of pi plus cosine of square root of pi minus, what about the value of this when p is 0? 0 times cosine 0, sine 0 plus cosine 0. Okay? We can't simplify this anymore, no? So that is what? Still square root of pi sine square root of pi. And then plus cosine square root of pi. Sine 0 is 0. So this is 0. Cosine 0 is 1. So minus 1. Oh, that's it. Or if you want to approximate, what's the approximate value? Take note of square root of pi there is a real number or in radian measure. Be sure your calculator is in radian measure. You set it in radian measure, guys, huh? Is that clear, guys? Sine, let's say, so what's the value? Could you help me, guys? Square root of pi in radian measure, huh? Guys. So again, square root of pi times sine of square root of pi so this is supposed to be in radian measure. How will I change this to radian measure in my calculator? Check my value, guys, huh? Once I finalize it. Cosine of square root of pi, then shift radian, then minus 1. Could you please check if my value is correct, guys? What did you get, guys? 5.3. So siguro 4 decimal enough. Am I correct, guys?
Yes, sir.
Yes, sir.
Are you sure? Guys, ha?
Opo, sir.
Okay, so number 6. Again, ha, if you're having trigonometric functions, always use real number or radian measure, ha? Do not use degree measure. When you take, let's say you have inverse trigonometric functions, your output should be real number or in radian measure, not degree measure, okay? Let's have this one. Integral from 0 to pi over 4 of 1 plus, sorry, 1 plus tangent of theta secant squared theta d theta. Okay? So how are we going to evaluate this? So we can evaluate this either taking the whole thing as u, or you can have individual integration, no? For secant squared, then the other one is secant squared tangent. So let's, what do you want, guys? Individual or integration term by term, or taking the whole 1 plus tangent theta as your u? Guys, or no comment? Let's have individual. 0 to pi over 4, then multiply inside secant squared theta plus tangent theta secant squared theta. Quantity d theta. So let's integrate this term by term. What's the integral of the first term? Tangent, no? Integral of secant squared theta d theta is tangent theta. So this is power, general power. Our u is tangent. Our du is secant squared theta d theta. So what's the integral? Tangent theta quantity squared, no? So tangent squared theta all over 2. U to the n plus 1 all over n plus 1. So evaluated from 0 to pi over 4. Okay? Evaluate this indefinite integral when theta is pi over 4. Tangent of pi over 4 plus 1/2 of tangent of pi over 4 quantity squared, or tangent squared of pi over 4. So minus, what about the value of this indefinite integral when theta is 0? Tangent 0 plus 1/2 tangent squared of 0, no? Okay, guys? What is this equal to? 1 plus 1/2 times 1, that is the tangent pi over 4, then square it, minus tangent 0 is 0, so therefore everything is 0. Okay? So this is equal to 3/2. Am I correct, guys? See? It's very easy. Is that clear, guys? So let's have some more. Number 7. We have integral of so let's say 0 to 4 of dy times y, yan, all over, then let me rewrite it, y dy over square root of 1 plus 2y. Okay? So how are you going to evaluate this, guys? You can apply what? Algebraic substitution, huh? Actually, you can apply basic integration, but you need to manipulate. So, but let us have it by algebraic substitution. So, by algebraic substitution, we have what? So, let's say x, let x be equal to square root of 1 plus 2y. When squared, we get x squared equals 1 plus 2y. Getting the differential of each side, we have 2x dx, and that is equal to 2 dy, right? Or we have x dx is equal to dy. Am I correct, guys? Then, instead of later going back to the original variable, so we can evaluate this integral even your variable is in x, but you have to change the limits because this 0 and 4 are for values of y. Okay? So if you are not going to go back to the original variable after evaluation of indefinite integral, so you have to change the limits so that your values will correspond to the variable x. Okay, guys? So let us have change of limits. So how to change the limits? Change of limits. So meaning, from values of y, we're going to have values of x. So we have x, original variable, and then, y. Then we're going to have now the variable x. Originally, what are the limits, guys? So 0 and 4, lower, upper. So corresponding to 0, so you go back to your representation here. X is equal to square root of 1 plus 2y. When y is 0, 1 plus 2 times 0 is 1. Square root, that is equal to 1. Am I clear, guys? Guys, so again, if y is 0, what's the value of x? X is equal to square root of 1 plus 2 times 0, and that is equal to 1. What about if y equals 4? So we have x is equal to square root of 1 plus 2 times 4, that is 9, no? So square root is 3, okay? So here, corresponding to y equals 4, so when you are now in the x variable, the value is what, guys? 3. So you're going to evaluate this instead of from 0 to 4, you evaluate it from 1 to 3. But remember, your variable is in x. Okay, guys? Is that clear, guys? So let's now have the substitution. Remember the representations we have, guys? So it's integral from 0 to 4, y dy square root of, let's copy that problem. This. So we now have this integral as what? Equals, what's the numerator, guys? Y dy. What is our y dy? Guys, look at this. Yung y natin is what? Ang y natin is x squared minus 1 all over 2. Okay? So, we have x squared minus 1 all over 2. That is my y. What is my dy? X dx. All over, this is x. Is that clear, guys? Okay? So simplifying this, we get What is the simplified form? I can put the 1/2 out of the integral sign. So integral from 0 to, by the way, not 0 to 4, no? Ano na limits kapag x na? Guys? Guys, 1 to 3. Oh, that is now from 1 to 3. Am I clear, guys? If you change letter, you have to change also the limits so that you're not going to go back anymore to the variable y. But if you retain the variable, then you don't need to change the upper and lower limits. So this is now equal to x squared minus 1 all over x, then dx. But cancel ang x, no? So we just have x squared minus 1. So this is equal to 1/2. What's the integral? So we have x cubed over 3 minus x evaluated from 1 to 3. Again, because I did not go back anymore to y. So variable, so I am going to use the new limits corresponding to 0 and 4. Sa y, sa x now we have 1 to 3 respectively, no? Yan. So getting 1/2. So this is equal to 9 times 9. This is 27. Can I do that mentally, guys? Or do I have to write? 3 cubed over 3 minus 3. Then minus the value of this inside when x is 1. So that is 1 cubed over 3 minus 1. Or simplifying, we have what? This is 9, no? Minus 3, then minus, this is 1/3 minus 1. That is negative 2/3. So positive 2/3 now. Am I correct, guys? Let's find the value. That's my calculator. So 1 divided by 9. 9 minus 3, that is 6, plus 2/3. That is 20 over 3. Divided by 2, so getting 10 over 3, guys. This is 10 over 3. Okay, guys? Guys? Any question, guys? So let's have another one here. Number 8. No? Is it 8? Okay, number 8. Integral from 0 to ln 6. And then we have in the numerator e to the 2x dx. E to the 2x dx. In the denominator 3 plus e to the x. 3 plus e to the x. Any suggestion, guys, of what we're going to do for us to be able to evaluate this? Guys? So again, we can apply what? Algebraic substitution. Huh? Let's apply. So by algebraic substitution, so let y be equal to, let's have this radical, square root of 3 plus e to the x. Then we have what? Y squared is equal to 3 plus e to the x. Getting the differential of each side. 2y dy equals e to the x dx. Okay? Now, since I do not want to go back to the original variable x later, once I evaluate the actual definite integral, so I'm going to have change of limits. Of course, if you do not want to do change of limits, you have to go back to the original variable. Okay? So we have change of limits. Originally, we have x, and now we have y, no? If x is 0, what is the value of y? So you go to this representation. So what is y, guys? So we have square root of 3 plus e to the 0. This is equal to square root of 4. That is 2. What about if x is equal to ln 6? So square root of 3 plus e to the ln 6. But what is ln 3 ln 6? That is simply 6 plus 3, 9. Again, 3 plus 6 is square root of 9. So that is 3. Okay, guys? So corresponding to ln 6 for y value, we have 3. So we are now going to evaluate it from 2 to 3 instead of from 0 to ln 6. So the new integral now, in terms of y variable, we have integral from 2 to 3. And again, what is e to the 2x dx? I have to give 1 e to the x to dx, no? So that I can have that 2y dy. So e to the x is y squared minus 3. So again, I'm going to split this part, yeah. That part, I'm going to split this into what? Into e to the x times e to the x dx. So e to the x is what? Y squared minus 3. And e to the x dx is what? 2y dy. 2y dy all over this radical is simply y. So y is cancelled, getting this 2. I can put that out. Integral from 2 to 3. And then simply y squared minus 3 dy, okay? And this is equal to, what is the indefinite integral of this? Y squared minus 3 quantity dy, y cubed. But remember, we have multiplier to outside. Y cubed over 3 minus 3y. Evaluated from 2 to 3. And this is equal to 2 times. We have 27 over 3 minus 3 times 3, 9. Minus, this is 8 over 3. Then minus 3 times 2, that is 6. As you become familiar, you can omit some steps. You can sometimes evaluate directly. So we now have 2 times. What is this equal to? This is 9 minus 9, 0. So we now have just 8 minus 3, or 8 over 3 minus 6, then negative outside. What is that equal to, guys? 8 divided by 3 minus 6. That is negative 10 over 3. Preceded by negative, that is positive 10 over 3 now. What's the value, guys? Guys. 20/3. Do you have any question with this, guys? No question. Let's have this number 9. Integral from 0 to pi/2 of sine cubed beta d beta. Okay, Dominique. What are we going to do with this? Are we going to evaluate the corresponding indefinite integral? By what, guys? By trigonometric transformation, huh? Trigonometric transformation. This is the odd case. Special form of integral of what? Sine to the m u cosine to the n u du, no? Where cosine is not present. So odd case, I'm going to split this into quadratic sine raised to 1 for this case, and then you're going to segregate, or you're going to separate what? One sine, meaning one linear. This will serve later as the differential of what? The sine beta d beta, differential of cosine, no? So we have to transform this sine squared into what? 1 minus cosine squared, no? So 0 to pi/2. Notice that I did not change variable, huh? So the reason why I retain 0 to pi/2. So we now have 1 minus cosine squared beta. So that is the transformation that we're going to do for sine squared, which is its identity, no? Times sine beta d beta. So let's integrate this term by term. So integral from 0 to pi/2 of, so the first term we have sine beta d beta minus cosine squared beta d beta, na? Yan. Okay, guys? And this is sine beta, then quantity d beta. Yeah. What's the integral of sine beta? Negative cosine beta. The derivative of cosine is negative, so this negative is needed as part of the differential. So I will now have positive here. Then cosine cubed, because that is power formula, GPF. U to the n, and then the d is negative sine beta d beta. So u to the n plus 1 over n plus 1. So again, evaluated from 0 to pi/2. And this is equal to negative cosine pi/2 plus 1/3 cosine of pi/2. This is quantity cube, no? That cosine. Okay, guys? So cosine cube of pi/2. Actually, cosine is of pi/2 is 0. Minus, so negative cosine 0 plus 1/3 cosine cubed of 0. Okay? Again, this is 0. This is 0. This is 1, so negative 1. So we have negative 1. Cosine 0 is 1 raised to 3. 1 pa rin. So plus times 1/3, we have 1/3. Negative 1 plus 1/3 is negative 2/3. negative, therefore, it is now positive 2/3. Am I correct, guys? Guys? Not talking, guys? Guys?
Yes po, sir.
Okay. Let's have number 10. We have, for number 10, integral from -5 to -2, 3dx all over x squared minus 3x. By the way, when you are evaluating definite integral, be sure your integrand will not encounter undefined value between -5 and -2, meaning between a and b, no? Including a and b. So ito, nagsi-0 siya sa x equal 0 tsaka sa 3. Yan bang 0 at 3 ay nasa pagitan ni -5 at -2? Wala naman, di ba? So, you can proceed kasi if, let's say, 0 happens to be in between A and B, so it means we can't evaluate immediately. That is not under what we consider, no? What we have considered. Because what we are considering, those definite integrals where f, your integrand, is continuous on the closed interval a to b, meaning from value -5 to -2. Okay, guys? So we can evaluate this by what? By partial fractions, no? Yan. So we have 3 over x times, what is the factored form? X minus 3, no? So corresponding to x, this is case 1. A over x, that's the partial fraction corresponding to that. For x minus 3, we have b over x minus 3. Yan. Okay? So I thought you already know how to solve for a and b fast, no? So we evaluate this expression 1 over x minus 3 when x is what? When x is 0. So when x is 0, but there is 3 here. We evaluate this when x is 0, but removing x. So we have 3 over 0 minus 3. So that is -1. For b, we have 3 over x evaluated at x equals 3 this time. Meaning we remove x minus 3. So that is 3 over 3 and giving 1. Okay? So we now have the equivalent integral. Integral of negative. So from -5 here to -2 dx over x. Plus, you have another definite integral. From -5 to 2 of 1 dx over x minus 3. Okay, guys? Yan. So we have negative ln of. So we have absolute value of x, no? Plus ln of absolute value of x minus 3 d over u. Evaluated from -5 to -2. So negative ln of absolute value of -2, that is simply negative ln 2 plus ln of -2 minus 3, absolute value is 5, no? Yan. Minus negative ln of absolute value of -5 is 5. Then plus ln of -5 minus 3, absolute value of that is 8. Okay, guys? Did you get that, guys? Okay. So we now have, let's arrange. So this is ln 5 minus ln 2 plus ln 5 and then minus ln 8. Am I correct, guys? So and this is equal to 2 ln 5 and then minus ln 2 minus ln 8. How do we write this as a single logarithm? Ln of, in the numerator, this means 5 squared. So ln 5 squared, 25. If difference of logarithms, so ln logarithm ng quotient. So we multiply this 2 times 2 and 8. So that is 16. Okay, guys? Yan. So that's the value of this definite integral. Any question with that? Let's have the last one. 11. So we have integral of is 1 from 1 to square root of 2 of dw over w squared square root of 4 minus w squared. Okay? This is solvable by what? We can solve this by or evaluate this by trigonometric substitution. Huh? So by trigonometric substitution. Okay, guys, still alive?
Yes po,
Guys.
sir.
So, what substitution are we going to use, guys? Yung pinaka-u squared natin is w. So let w be equal to a. That is 2. Since this takes the form of a squared minus u squared, so we have sine theta. So dw is equal to 2 cosine theta d theta. So that we're not going to go back to the original variable, let us have change of limits. Change of limits. When you change the limits, we now have from original w to the variable theta. So let's have for sine theta. And then what is theta, no? If you have, let's say 1. So 1, may w. What is sine theta? 1/2. What is at that angle in the first quadrant? Because this is positive. So we agree that we deal with first quadrant and fourth quadrant only for the angle theta. So if sine theta is 1/2, what is theta? 30 degrees. So that is pi over 6. If you have a square root of 2 for w, so w equals square root of 2. So what is sine theta? It's square root of w over 2. It's square root of 2 over 2. That is sine theta. What is that angle? If you take the sine of that, it is square root of 2 over 2. That is pi over 4. Am I correct, guys? Guys? Am I correct, children? Guys, you do not want to reply? Okay. Again, sine pi over 4 is square root of 2 over 2, right? So the new integral now becomes what, guys? Integral from pi over 6 to pi over 4. Oh, what is dw, guys? Ano yung dw? 2 cosine theta. 2 cosine theta d theta. What about w squared? So that is 4 sine squared theta. What about square root? So we have square root of 4 minus 4 sine squared theta. Okay? Yan. This expression inside this one, this is 4 1 minus sine squared theta, no? And this is equal to 4 cosine squared theta. Okay? So what's the square root of that? Guys, integral from pi over 6 to pi over 4. So 2 is cancelled here. So we have simply positive 2, no? This is positive 2 now here. And then this is 4 cosine squared. What's the square root? Guys? So we have 2 sine theta times 2 the square root cosine theta. That's the square root of this, no? Numerator, we have 2 cosine, just cosine na lang. Cosine theta d theta. Oh, what are the things that you can cancel further? Cosine theta, no? So this is equal to, guys, 1/2 integral from pi over 6 to pi over 4. Oh, what is left, guys? Ano na lang natira, children? Sine squared pala to, no? Sorry. This is sine squared. Sine squared. Oh, what is left, guys? D theta over sine squared inside. Meron pang 2 rito, no? So 1/4 outside total. Guys, 1/4. Let me erase this. 1/4. Oh, here, guys. D theta over what? Sine squared. Do you know what 1 over sine squared is, guys? Guys, that is 1/4 integral of cosecant squared theta evaluated from pi over 6 to pi over 4. Getting 1/4, or what's the integral? Negative times 1/4 cotangent theta. O see, very easy now the integration. Evaluated from pi over 6 to pi over 4. So negative 1/4. What's the value of cotangent pi over 4? And then minus cotangent of pi over 6. And that is equal to negative 1/4. This is 1 minus square root of 3. Am I correct, guys? Guys?
Opo, sir.
This is also equal to square root of 3 minus 1 all over 4. If I multiply negative inside, so this is now positive, negative, positive, negative. So square root of 3 minus 1 all over 4. Alternative form. Okay? There are calculators capable of evaluating definite integrals. And I know you know that, no? But of course, a board exam very useful. But you should know how to do it manually, no? Also. So you can study working on definite integrals using your calculator. And be sure your calculator is in radian mode, huh? If you are entering limits involving trigonometric functions. If trigonometric functions are involved, you have to be careful. Be sure your calculator is in radian mode. Or it is safe to be always in radian mode, your calculator, so that every time you encounter trigonometric functions and you have definite integrals, no problem anymore. Is that clear, guys?